If you recall from the last slide, we had a little diagonal line when we plotted our position versus time. It looks something like this, and we had some dots along there. There's one, there's another, and there's another. Now, anytime you see a line in physics, you should get really excited because you have the opportunity to calculate the slope of a line. And so if this is new to you, you want to spend some extra time with one of the skills tests that challenges you to get the slope of a line. But if this is old hats, this should be pretty straightforward. Slope is usually given by an m. In order to find the slope of a line, what you do is you take the y-coordinates of, let's just pick a point. Let's pick this point. I'm going to highlight it in blue. Let's choose this point here. And we look at the coordinates of that point. Notice it's got an x-coordinate of 2, and it's got a y-coordinate of -2. So I can actually write the coordinate pair for that particular point. So that'll be, I'm going to put the 2 in blue. And then let me choose another color. Let's let our first point be in orange. We'll call this point the first point. So its values are, it's got a y value of 1, I'm sorry, an x value of 1 and a y value of -1. And so now we're ready to do the calculation. So again, the slope is given by the y value of the second point minus the y value of the first point divided by the x value of the second point minus the x value of the first point. So it turns out that the y value of my second point was -2 minus the y value of my first point, which was -1, divided by the x value of the second point, which was 2, minus the x value of the first point, which was 1. And so I wind up with -2 minus a -1. Well, if you remember, when you subtract negatives, that's actually like plus. So -2 plus 1 winds up being -1 in the numerator. 2 minus 1 is 1, and therefore the slope of my line here is -1, which again makes sense because we said this should be a negative slope because it's a line that goes down when you go from left to right. Notice I'm just doing the numbers here. I'm not paying attention too much to the units, but if I really wanted to care about the units, my y values are, these are, of course, remember these are positions. So it's -2 meters minus -1 meters. So these are, if I really wanted to put units in here, I'd have meters here, meters here. That still lines up, or perhaps it's centimeters. It's some sort of a distance. So forgetting about the numbers for the time being, my units of my numerator are in some sort of a distance, meters. The units of my denominator are in units of time, which turns out to be seconds. So sure enough, not only is the number of my slope significant, but actually the units of the slope are also significant because meters per second should ring a bell. You should have seen these kind of units before. Anytime you have a distance unit over a time unit, we're talking about speed, or in this case, velocity. So what you're actually calculating here is the average velocity of your moving object.